Okay, thanks everyone for being here. Thanks Microsoft for inviting us to present their event. I want to talk a little bit about Automation Anywhere, what we do, demo of our product, and how we integrate our services with Microsoft Cognitive Services to make the workspace different. How do you use automation to make the workspace more efficient? So I'm Bruno Selva. I'm Director of Product for our Cognitive Solutions. And we also have Kevin Chan that will join us in a moment to talk about our integration. So what is the digital workforce platform? Automation Anywhere delivers a workforce platform that makes work easy. We combine bots and humans to make the work easier, to make the companies more efficient, and get better results when you're working. So there are three components of it. The first one is RPA. So RPA can automate tasks based on on what the human do. So you can teach bots how to replicate some tasks so you can automate a process. One example of a process is invoice payment. So normally there are several steps a human needs to take to automate this process. So first you open your email inbox. Then you get, from the email, you get an invoice. You save that invoice to a folder. Then you open an Excel file or an ERP system, you take data from invoices, you put in that system. You send an email to a second person. The second person will open the email, verify information, go to the bank, and make the payment. So it's a simple process for a human, and you can teach the bot how to do that. So using Automation Anywhere, you can take all those steps, you just drag and drop components, and you can replicate this process thousands of times, and then the human can do a work that's better suited for a human. The second component is the cognitive component. So some of those tasks will require some human decision, human judgment. So for example, if you need to decide, is this a fraud or not? Now, you cannot apply rules to the process. There are thousands and thousands of data points that the computer can analyze so it can make a decision. So using cognitive components, you can train a system, train models, so the computer can think as a human. And the third one is analytics. So after you have all those processes flowing, all those bots doing the work that normally a human would do, you just need to put in a screen, in a dashboard, so you can take some insights and make your process better. So that's how we build our digital workforce platform. And today we want to talk more about the cognitive aspect of it. So Microsoft is one of our partners, and it builds a lot of AI solutions. And if you go back to the example that you want to automate a process end-to-end, RPA is a very good vehicle to deliver that. So we work with multiple partners, and we adapt their solutions, their AI solutions, various components to orchestrate AI so you can deliver a process end-to-end. So you have a framework that you need to build your models, you need to train your models, run, and you have a feedback loop to get the system that can learn and improve over time. And one of the examples I'll show is IQBot. IQBot is an application we built to understand documents, understand variations of documents and different types of documents so you can automate the processes. So the first step is build. So we build models in-house. We from Automation Anywhere, we build models that can understand documents. The second step is training. So the user has a specific document. Let's say it's a bank statement. So you show to the computer and you teach the computer what do you want to extract from bank statements. So that's the training part. When you deploy this in production, RPA will take any document you have in your system, send to IQBot. IQBot will extract information and then gives back to the rest of the process. But because an AI model, it's based on statistics, sometimes it might fail. The accuracy might be low, the confidence scores might be low. So you have a feedback loop. So in the third phase, if something fails, the system will get the errors from a human, and then you get the feedback, and the system learns from it. So for IQBot specifically, we did the first step of this integration with Microsoft. IQBot could not read handwritten information. If you had any document with handwritten information, IQBot would just fail. So we integrate with Microsoft and their cognitive services that can understand handwriting information. So handwriting is a hard problem. It evolved over time, and Microsoft now is providing a very good solution for that. And that's why we decided to use Microsoft for that process. So to do the extraction, there's a lot of processes that IQBot uses, different AI models, and one of them is provided by Microsoft. So to demonstrate what I'm talking about, there's one demo I would like to show. That's the insurance claims processing. So when you have an accident, you hit your car, you need to contact the insurance company and provide some information for them. So you have a claims form that you fill with the information about the accident. You take pictures of the car. And then based on the information you send, there's an agent that will evaluate, okay, what's the data here? How much it will cost to fix this car? Get data from policy information, and then pre-approve or send the process for a review. So we can replicate that, and the computer can do the same that the human was doing, so your process become more efficient. So in this case here, sorry, yeah. So in this video here, you see all those steps. So first, you send all the data to the insurance company. You send the picture to IQBot, and you train IQBot. The first time you just train IQBot, so IQBot will learn all the data in this form, and all forms similar to those. So after IQBot is trained, you don't need to do any more work. IQBot will know how to process this kind of document. So once IQBot is trained, you can send this to production. You can put the document processing inside your bot. And this bot here that will show, we will not only have the document processing, but it's using a second service from Azure that can, based on training of thousands of pictures of accidents, it will know how much it will cost to fix this car. So in this case here, in the form, the customer was requesting $8,800 to fix the car. And the Azure model is saying that it's probably costing $6,000 to fix this car. So the benefit of combining AI with RPA is that you put all your AI behind business logics, and you can combine multiple AI solutions to make your decision. So if you want to prove this, this process here, you have a set of rules that you apply on top of AI. In this case, we're comparing the amount requested, $8,000, with the amount identified by the model, that's 6,000. And the decision the computer is making is that you need a manual review. So RPA can take all this information, send to an agent, and say, I need to review this case for this reason. So now you can make everything a lot more efficient. If the system is confident enough, it can automatically approve processes, and instead of reviewing hundreds of processes, maybe a dozen of them need to go to a human. So I'd like to call on the stage Kevin. Kevin is from our solutions team, and he did an amazing job to integrate Microsoft solutions with Automation Anywhere, and he showed how we did that. Thank you. Thank you, Kevin.
All right, thank you, Bruno. Thank you, Bruno, for the great introductions. So I want to show you under the hood that how we integrate Azure into the IQBot OCR engine. But first, I want to make sure everybody know what OCR is. So OCR is basically optical character recognition. Simply put, it's a have machine to recognize text. But first, you must ask why. Why Microsoft? Why Azure? There are plenty of vendors out there. The reason is pretty simple. It's because that Microsoft has everything that we are looking for. First, the cognitive API must be able to extract text from handwritten document or form. Like Bruno said, the handwriting text can be very, very tough for OCR to recognize. And second, to be able to extract text from complex document, document with complex background image or watermarks, such as driver license or passport. Third, the API must be able to support both on cloud and on-prem solutions. Many of our customers simply do not want to process the highly sensitive data outside of the network. So on-prem is actually very important to our customer. And last but not least, we are looking to partner with companies like Microsoft so we can take advantage of the machine learning R&D we're not looking forward to, we're not looking to reinvent the wheel, but simply build a better AI product. I want to show you some of the example, what I described above, so you have better understanding of our challenges. So here's a sample of an Arizona driver license. And as you can see, the background image could contain all sort of image pattern, and even some of them could even contain text, like government seal or sort of things like that. So it makes the OCR very difficult to recognize what is a real text and what is not. And here's a sample of the invoices with a script style handwriting. So scripting is one of those handwriting style that I thought is very difficult to read. Personally, I couldn't really read that well. And last is the handwriting text in a form-based type of documents. As you can see, there are lines, there are boxes, and that can definitely confuse the OCR from reading your text. So the Azure OCR engine contains 4 steps. First step is to analyze your document with the Azure API. And based on the result, it will review all the low confidence area and reprocess it. And after that, the engine will look into any misspelled word and see if it could easily pick up some of those misspelling and auto-correct it. And last, it will analyze the content density. And I'll show you the detail of each step. So the engine converts the document into a series of images. So it sends each of the images to Azure Computer Vision API. If you have done Vision API before, the response will look actually very familiar. The response contains information such as text, bounding box, and confidence. So visually, it looks like this. So all the highlight are what we call the text segment. Green mean high confidence and red mean low. So keep in mind, green confidence doesn't mean the text is always accurate. But low confidence, and also that low confidence doesn't mean the text is always inaccurate. However, the chances that the low confidence has an incorrect text is much higher. So it's all about probability. So what do we do with the low confidence text? What we do is that we take the result, we black out the entire document to isolate the noise, except the low confidence area. Based on our research, machine learning works better if the image only contains a single line of text. However, process one line at a time is simply not feasible in terms of performance, in terms of cost. So we resend the isolated version of the image to Azure API to reprocess. And in this particular example, as you can see, that there are a number of areas the confidence has increased. It doesn't happen all the time, but when it happens, there is a 5 to 10% chances that your accuracy will improve. So we definitely take that chances. And step 3, the engine will take advantage of Azure Spell Check API. So in this particular case, orange is misspelled, and the API could easily just pick it up. The API doesn't have to scan every single text on the document, and it can only focus on the pure text segment. Any segment with number, with date, the spell check API won't help you that much. And spell check is an old tool, but it is a great tool. So you definitely should take advantage of that. The last segment of the engine is to look over the density of the content. As you can see, the word county is actually overlaps with Anaheim and Orange. The reason why this is necessary for the engine to perform is because that when the segment is overlaps, it's very difficult for the classification engine sometimes to pick up the right information. So the OCR engine will create some separation in between to make sure each bounding box is an individual bounding box instead of overlaps with the other. And it also provides the UI much cleaner data for user to process. So I go back to the slide that Bruno is talking about, that why OCR is important, because that OCR is actually a vital process of the IQBot pipeline. If OCR is unable to produce accurate data, then IQBot pretty much cannot output the correct data as well. So Azure Vision API is able to help us to address many of these issues. And the good news is that if you implement the Azure Vision API, it will work in both on-prem and also in Azure Container. So you get the best of both worlds. All you have to do is simply change the endpoint to wherever your container is being deployed. So after the OCR engine processes all the data, it will send all the data to the IQBot classification engine to continue to process. And that's all I have today. Thank you. If you have any question, feel free to come to our booth. It's just right behind you right there. And we can go over a lot of technical design and also any IQBot question that you have. Thank you.